Okay, so it's kind of crazy. Ever since I started this channel, the most popular video by far has been the Web Hacker Basics video on local and remote file inclusion. If you haven't seen it yet, that video breaks down how to exploit simple file inclusion vulnerabilities in the Vulnerable Lab DVWA. So, with as popular as that video's gotten, I figured now would be the perfect time to revisit file inclusion and talk about how to exploit them using a real-world example. I'm talking default configuration and the latest version of PHP. What's going on, guys? Welcome to Netsec Explained, and in this video we're going to cover how to find and exploit file inclusion vulnerabilities using PHP wrappers. Just to keep everybody on the same page, let's start from the top. File inclusions are a class of vulnerabilities that allow you to call and execute server-side scripts. You'll most likely see file inclusion in PHP, but I found them in both Java and .NET pages too. The OWASP testing guide actually has a pretty good breakdown of what we need to look for. You can see here, from a black box perspective, we're looking for some sort of URL parameter that accepts a file name or partial file name as input. We can just change the value of the file path and access any other file on the system. If we look at the source code, we would try to find where the application was importing the file. In PHP, this will either be a require once or an include function like you see here. Cool. So now that we know what we're looking for, let's get our lab set up. Okay, so I've gone ahead and created some Docker labs for us, and you can find them on my GitHub here. If you've never used Docker, you should check out my video that I made a little bit ago. So what we're going to do is download Docker, which I already have done here, and it's going to be in file inclusion and college website. What we can do once we're in the directory is docker compose up build, and that's going to build the environment for us. It's going to set up our database and it's going to set up our PHP system. This is a recent open source student project I found online. I found these kinds of projects to be a great testing ground for beginner bug hunters, just to kind of see what a real world application looks like, or at least a fully developed application. So the first thing we want to do is check the source code and see if we can find any sort of inclusion opportunities. So as we saw earlier, I'm going to zoom in a little bit. As we saw earlier in the OWASP page, what we want to do is actually find a require once or an include with a PHP variable. So PHP variables, they use a $. So what I'm going to do is press Control-Shift-F, and this is going to find all. And what we're going to want to look for is the term include, and then we can use regular expression, and that's what this $* over here means. So we can use regular expression $* question mark in order to say it needs to have include, and then it doesn't matter what else there is in there, but we need to have some sort of variable. So I'm going to do $$, and we can see here our index.php does just that. So here on line 163, our index.php takes this page variable and adds a .php at the end. So we need to figure out where this page variable comes from. So I'm going to press Control-F and look for $page equals. And we can see here on line 86, page is actually from isSet get page. So what this means is a get parameter. If there is a get parameter called page, it's going to set that, and then it's going to go ahead and include whatever file we add into there. Now let's take a look and play around with the vulnerability. So I'm going to go ahead, open up my Firefox. I'm going to reach out to 127.0.0.1, and then this is running on port 8081. And here is our website. So I can go ahead, click on some links, courses, about, milestones, and you can see this page variable up here at the top. This is the page variable from that index.php. So we can infer that this is calling a home.php file, a courses.php file, about.php file, and then a milestones.php file. This is what we're looking for. And if we look at the source code, we can see there's an aboutus.php, a courses.php, and a home.php and milestones. So let's jump back over to the browser. Now, one of the things that we want to try and do is probably read the Etsy password file. At least that would be one of the first things that we would try to do. So if I type in .. We don't know how deep this is, so I can just keep adding directory traversal characters and then do Etsy password. We get an error, or at least it won't let us read any sort of file here. And the reason why is because what this is doing is adding a .php to the end of the Etsy password. If there was a PHP error, it would tell us that. Now, if you Google how to bypass adding a .php to the end of a file include, there's usually two techniques that'll pop up. The first one is trying to append a null byte to the end of a file name. So this will be Etsy password, and then the null byte will end it, and it'll completely ignore the .php at the end. Unfortunately, this has been patched in PHP 5.3. so it won't work for an updated system. The other thing you'll come across is file truncation. So PHP used to limit file names down to 4096 bytes. So to get past this, you would just need to pad the input of Etsy password with a / character in order to hit the 4096 character limit. I say used to because this has been patched in PHP 5.2 several years ago. It's probably here that some of you watching might say, well, what about remote file include? We can add our own address and have the server pull a .php file from our own server. That's not going to work here either. In a fully patched PHP system, the server will not accept references to outside resources by default. You have to really mess up that configuration to allow that to happen. So remote file inclusion, they're rare and almost impossible to find, given the default configurations. Now, we're kind of stuck accessing only .php files on the local system. Fortunately, in PHP, we can use something called a wrapper. A wrapper allows users to interact with various I/O streams, including file I/O. So let's take a look at some examples. So what we can do is look for Payloads, all the things. Open up their GitHub and try and find their file inclusion information. This is a pretty good resource. So what we're interested in are the different types of wrappers. We have PHP wrapper, we have a zip wrapper, data, expect, input, and var. With the default configuration in a fully patched system, the only one that's really going to work in our case is going to be a PHP filter. If you notice here, what it will do is try to encode a file. So for example, you can ROT13 encode or base64 encode, and then you can call a resource, which would be something like index.php or any other .php file. In our case, what we're going to do is look at a file on the system, but we don't need to add .php. That's added by the application server itself. So let's go ahead and try to exploit this. In this case, what we're going to do is grab this PHP wrapper and see what this does. So if I set my page to something like index.php, and I forgot to remove the .php, there we go. Now we see all this base64 information. So let's see what this decodes to. I'm gonna go ahead and copy, and then check out CyberChef, which is a great resource for decoding and encoding information. So I'm gonna paste that in here. I'm gonna set this from base64. And you can see here, what this PHP wrapper does is turn what was a black box test into a white box test. And so now we can read the actual PHP source code in the application. Normally, the PHP code in the local file would be evaluated by PHP, and then all other aspects of the file would be returned to the browser. In other words, the user should never be able to see the PHP code. But the reason why this works is because we are encoding the PHP file before the server has a chance to evaluate it. Since there are no PHP tags after encoding, nothing is evaluated and the whole file is returned to the user. Now, what's interesting is we see a reference to this admin dbconnect.php file. So let's see what this does. So if I go ahead, copy this, jump back to the website, remove index, and then get rid of the .php since that's going to be added by the application. I'm going to go ahead and hit enter, and I get a new string. So let's copy, paste, and here we have the MySQL root password. Cool. So hopefully after watching this video, you were able to walk away with a few new skills. We did a deep dive into file inclusion vulnerabilities, what they look like and how they work, and we got to play around with some PHP wrappers to turn our black box test into a white box test. From there, we grabbed some credentials that we could use to further our attacks against the system. If you want to challenge yourself even further, there's a handful of other vulnerabilities in this application that you can play around with. Take a look at the source code and see if you can find a way to get remote code execution or shell access on the system to find the second flag. Well, that's all I have for you guys today. For more information, check out the links in the description below, and don't forget to like and subscribe to see more videos like this. I'll see you next time.